Hello, my name is Wolfgang from IntelliTrend, and I have the pleasure today to be here, and I enjoyed so much, and I think you all enjoy to be here on Presence this year. Yeah, and I'm going to share with you the presentation of real-world examples for integrations and extensions in Zabbix. And before I start with our examples, just some ideas or some info about how we did actually implement those extensions. So if these are front-end modules, then these front-end modules uses the official Zabbix front-end module API, which is very well documented. If these are back-end services or extensions to the back-end infrastructure of Zabbix, even in combination with Zabbix modules, then we are also using this Zabbix RPC API, which is maybe well known. I've seen a couple of workshops about the API integration. And this API can also be used within a front-end module. So in this case, you would use the front-end module API to integrate your front-end module into the Zabbix front-end framework. And within your module, you would then use the Zabbix API. And last but not least, some extensions I'm showing you are also using on top Zabbix database access. So let's start with the first one, and that is our host CSV importer. And the subline here says, I want to do it in Excel. And really that was the driving force to develop this front-end module. We have so many people, customers we're working with, requesting that they say we would like to, design or list our systems, our hosts in a spreadsheet, assign the host groups, assign the templates, all these sort of things. And once we have done this, we would like to import it in Zabbix. That should somehow be possible, yeah? But actually, it's not somehow possible. I mean, you can export and import hosts. You can use it using the template definition that works. But this CSV import is missing. So we just simply created a new front-end modules. And the requirement was that it should allow a simple import from CSV files, and you should be able to actually define your host, define the host interfaces, define the templates, define the host groups, and then it should be easy to implement it. Here you see a screenshot of the Zabbix menu, and where it shows up as a native front-end module. And that is how the extension looks like. It's just very simple, very straightforward. There's a checkbox, there's a combo box, there's an upload button, and then you upload your stuff, and then it will be imported. And also there's an example button, and the example button, if you click on that example button, then you get a sample spreadsheet, so you know how you have to name your fields if you would create your own one. Very, very easy, very straightforward, very simple, but quite useful. Yeah, and that is how the import process looks like. So you import your stuff, then you have a preview, and if you are happy with your preview, then you can finally create the systems in Zabbix. We made this module available on GitHub, so feel free to download it and use it. And it's also maybe, if you have not that much experience with Zabbix front-end modules development, then it might be a good starting point for you to create your own one, because it provides some functionality, has some form function, you upload some stuff, you process it, and so on. So it's useful. So it's good on its own, and it's a good starting point as well. Now I would like to show you the next one, the next example for a front-end module. That is our host group modules, our admin host group module. And the subline shows something like, or subtitle shows something like, I want to manage the IT by myself. And really, that was the driving factor for us to develop this module initially also for a specific customer request. You might remember the talk from yesterday from Nathan. Very, very nice talk. Thank you, Nathan, by the way. Very nice talk, and he mentioned how to structure things in Zabbix, how you can set up your Zabbix and keep Zabbix organized. And one important part of this talk was how to actually design and work with host groups, and how you set them up and how you define them at least. And As you know, I just heard we have a couple of new Zabbix certified specialists and professionals here. Yeah, so you all know that there's one specific role required if you want to play with host group settings, and that is the super admin role, right? So on one hand, you would like to actually design your host groups in a way that your specific IT department needs the host to be organized. And on the other hand, this requires a super admin role, and certainly you do not want to give any of your Zabbix users the super administrator role. So that is where this module comes in. So the requirements are that we have a frontend module that allows you to create host groups actually without being a super admin. However, it still requires you to be a Zabbix administrator, and it gives you limited access to your host groups, that you can set up child host groups based on the parent host group you have write access to. That's the idea, yeah. And this one is really, really helpful. I can tell you, we do a lot of transitions where we migrate isolated different monitoring systems within a company into a more centralized approach. And this one really helped a lot because people have, before the transition, 100% responsible for their own environment. They can do what they want. They are the master admin. And when moving into the centralized approach, they no longer have this master admin role in most cases. So this one really helped a lot. Yeah? And it's fairly easy to use. It's very easy to use. Yeah? Same stuff. It's a front-end model, very simple. You just select your host group. So you just, in the combo box, you see only those host groups you have write access to in your role, in your permission system. And then you can create a subgroup, and basically that's it. And you can work from there. So very useful extension, very helpful, and have been working excellent for us. And I hope it will help you too. And we made it also available on GitHub. Feel free to download. Look how we did it. Maybe you improve it. Maybe you have got a feature request. I don't know. It's up to you. So we make it open source. Yeah, take it. The next one is a little bit more complicated, a little bit different, and that is an extension we developed for service monitoring. And the subline here says, what makes up a service? So let me just start with our idea of service monitoring. So what is service monitoring in our understanding? So this example shows a web shop service, and this web shop service is built up on 3 services, which is a front-end service, a cache service, and a database service. So nothing special here. And each of that services itself is based on a cluster. So many hosts build this service. And if everything is working fine, we say that our service is in an okay state, so there's no problem, everything is fine. Now let's look into that we have a failure in our front-end server, so some servers are not working properly. Then we can say that our front-end service has an issue. Our web shop service will still function. It will have a performance impact, maybe. It might be degraded. It might be able to serve the same amount of users in the same time. But in general, our service will still work. So we will consider this service to be in a warning state. It's not really a problem in the sense of it doesn't work, but it's not okay either. Yeah. So I think all of you know exactly what I'm talking about here. Now, if all of the front-end servers are down, then certainly the web shop won't be available. Yeah, I can promise you. So our web shop will be in a problem state here, and that's really a problem if this is happening. Different story for the cache service. In this example, all of the cache server are down. No cache server is running, which means our cache service is down, is in a real problem state. Nothing is working there. Does it mean our web shop service is down? No, our web shop service works. It works with a degraded performance, but it's still working. So what I'm trying to make here, the point that I'm making in the slide is that on one hand, we have the requirement that all of the front-end servers are gone. Our web shop service will go away. while on the other hand, if all of the cache servers are down, then our service is still functioning. So we have different ways. We need to interpret this data in a different way. That's the point I'm making here. And the last point I'm making to make things more complicated is the example of our database service. Yeah? In this slide, we see that the database service is down, although one of the database server is still running. And we have a company policy here in place that says to avoid a split brain situation, at minimum, we require 2 database servers up and running. And this condition failed. It's just only one database server up and running, and that's why we consider our service to be in a problem state. So what I'm trying to say is service definitions can be complex, can have individual requirements, and it's not that easy and obvious on the first glance what service definition is made of. So how do the advanced services help that we, designed for Zabbix on top of the Zabbix service offering? The idea was that we integrate with the Zabbix service definition. So we're using the original Zabbix services as they are defined in Zabbix. We have service configuration still based on host and tags. There's a custom front-end module, and the important part is that it has some sort of a node-style visualization. So the idea was that we can really see the service in the front-end module. We can see the service definition. We would like to get a visual idea about how the service looks like in real time. And it also required some checks to make sure we have no misconfiguration. We have just seen the service chart, the service definition, and you can imagine there are a lot of system involved and there are a lot of dependencies and relations, and you can easily screw that up in the configuration. And to do all the service calculation, to do it in real time, to pass it over to the front end, etc., we needed to have an additional backend server that does all of the heavy lifting. Yeah? Or we have to go to Zabbix and ask them to change the Zabbix server engine, yeah? Which we might do, I don't know. So far we have a backend server. And of course, no modification to the Zabbix source code and initially developed for, etc. So how does it look like? This is a front end. That is a front end component. Very easy. Looks like a dashboard, and you see immediately how many service definitions, how many services are defined, how many hosts involved, how many triggers are related and contribute to the service definition, and then we see a list of services with a service state. Now that is nothing special. That looks pretty simple. But the interesting part comes if you open up a service definition. Then you see a flowchart, a diagram, and this one is not configured by, it's not created by you in terms of that you design a dashboard. It's calculated on the service definition in real time. So if you make a change to your service definition, then this flowchart will change in real time. And you can see in real time what on the right hand side, for example, we see hosts. In this slide, we see 2 hosts here. And you can see in real time which trigger makes up the host definition. You can see the trigger state, and you can see how the internal calculation for all the trigger states contribute to the final service state. And this is again updated in real time. This is a very simple example. We can do more complex examples. They're auto-scale, and you can zoom and do all this fancy stuff. Yeah. On the right-hand side, we see a couple of hosts. Those hosts show up the triggers that made up the service definition. We can see again here in real time the color indicating that we have in the middle some issues. Yeah, like I think that is a laser here. Yeah, like here, for example, we see that we have some issues, and how they contribute here, how the calculation is done. Yeah, so and that is all done in real time, and that effectively on the left-hand side shows you how we contribute to the services here. So this is a more complex setup of advanced services. Very, very useful, very helpful, and yeah, we have it in place in many customer sites. The next example I would like to share with you is about big data and big data in cloud environments. Now, And the topic here is metric streamer capture the value of metrics and events in large data sets. And I have to admit, I had better titles in the past, so this one really looks quite awful, quite technical. But in fact, it's what it's about. It's about capturing values from metrics, historical values, so the measurements by themselves, and events in large data sets. And imagine the following. Imagine that you have a larger corporation. You're working in cloud environments like in Amazon Cloud, in Google Cloud, or in Azure, whatever. You're running maybe your stuff in clusters, in Kubernetes clusters, or in hybrid clouds. And you have different monitoring systems. And that is usually the case if you're working in larger environments. There's not just one monitoring system, there are many monitoring systems. There is a vendor-specific monitoring system for Wi-Fi, for a power plant, for an energy generator, for a radio transmission station, you name it. So many different options. And these usually work on their own. And that's why I call them A, B, C, D, just to give them some name. And the idea in this project was that this big data collection thing, that we combine all the data from all the different data sources and put them to a central place, collect them in a central place. And then we can work with this data more centralized. So we can get access to data A, B, C, D, can combine them and can work with them. That's the idea here. So let's say we have different applications, like specific applications that would like to join this data. We have maybe a specific dashboard that does something, or a specific business analysis. That all would be possible because in this centralized data collection pool, we could access data of all of the systems. And the really nice part of this approach, if we follow this approach, if we think about this approach, the nice part would be that in this case, in integration from one monitoring system to another in terms of metrics, so like the historical values, but also in terms of events like alerts, is very easy to implement because there's no tight coupling any longer between two monitoring systems. Monitoring system, in this case here, this monitoring system would just subscribe to the central data collection bus in the same way as the application do here. Very, very simple approach, gives a lot of flexibility. So imagine this, you have some Wi-Fi specific infrastructure, you have your IP telephony infrastructure, you operate on a worldwide level, you have specific vendors that monitor this stuff, and you put all of this data in a central location, and then you can access it from anywhere and can combine it the way you want. Yeah? It's really a powerful idea. So to make this powerful idea a real-world idea, to implement it in Zabbix, what do we need to do? And what we need to do is we need to be able to publish from Zabbix either events, so trigger stuff like temperature is above 25 degrees, but also we need to provide the measurements from Zabbix, so the historical value that can be processed by different systems. And in the same way, we need to consume those values from other systems within Zabbix. So that's basically the design idea. So the requirements we have here is values of metrics and events must be exported using the JSON data format. So that is the common format across all of those systems. Exported data must be somehow transformable, which means that if I provide data in the Zabbix way, then some other systems would like to consume it in a different way. So we need to have the option to transform the data, very similar to the Zabbix preprocessors allows to preprocess data before they're finally stored. Exported data must be somehow filterable, so you don't want to export any of your data, but you want to export specific data, like you want to export your Wi-Fi vendor specific Riga data, for example, for an application. And we should be able to support different data sinks, so where the data is finally worked with. And we have actually a Kafka and NSQ. These are message brokers. Some of you will know them very well, I guess. And also we have database as a data sink from a type or flat file. And it should be possible to have multiple relations between data sources and data sinks on one hand based on filter settings. I will show it in a slide in a minute. And from a performance perspective, the requirement was about to roughly handle between 30 and 50K values per second, yeah, with this transformer stuff. And because it's a sensitive application in terms of it's a turntable, it provides data from system A to B and vice versa. So it's an important part of your monitoring infrastructure, if you put it this way. The software should be monitored by Prometheus or should have native monitoring options for Zabbix. Yeah, and it should, of course, work in cloud environments. Yeah? In fact, that was developed to work in a Kubernetes cluster environment. So that is a very, very simple idea about the design, very basic. Yeah. This example uses as a data sink a Kafka message broker as a message bus thing. And those of you working with MQTT and IoT are pretty familiar with the idea of a message broker, I say. We have on the left-hand side, we have our Zabbix Monitoring 1 system, and that is providing some specific data that it's publishing, that is collecting on one hand, but publishing, and you see we make a difference here between the metrics and the events. And on the other hand, we have this specific vendor monitoring system, this one here, the third-party one. And here we have our subscribers. Yeah? And you see that Zabbix 2 here also is interested in the metrics and alerts from our specific vendor system. Yeah? So that is the scenario we've just seen on the slides before. So that is the idea of the design. Then this is the actual implementation. And on the left-hand side, you see different data sources. So where can data come from? Could be different systems, could be database. We have a special understanding for the Zabbix database, so we understand what the tables are, what the API does, and how this data is structured. But in general, we can work with anything. One nice input here is the data source webhook. So every time you call this webhook, you can pass over to this webhook additional data the way you like. So it's in some sort of universal integration. It even works with very easy with Zabbix alerts, for example. You just set a webhook and say if the trigger fires, then it should call this webhook. Then you would have it on the message bus here. And then you see the component, the router component, and really what this one does is it defines the relation between the data source on the left-hand side, the filter settings, so which metrics I'm interested in, and which transformers and which data sinks are then finally put together. Yeah, so that's the routing component. So you can say, I would like to get all the webhooks with some specific information inside through the router using this line here, transformer 4, transformer 1, and that should be on the Kafka topic XYZ, for example, being published. So very flexible. The green ones are transformers. We have two types of transformers. We have template transformer and we have JavaScript transformer. If someone is familiar with the Golang language, yeah, these are Golang templates, native Go templates that can be used as transformer, but the most common one is really the JavaScript transformer, and they were pretty much in the same way as you would expect them when you look to the Zabbix JavaScript preprocessors. They work pretty much the same way. And you can change them any way you like. So that is the implementation. Here's an example, and if for those who are familiar with the Zabbix API, please note this is not a get item call. In fact, that is the data for just one historical value. This one is usually what you get. Yeah? So what we do is every single historical value is enriched with metadata coming for the item and coming for the host and coming for flags, tags, host groups, etc. Yeah? So that produces a mass of data. And that is why we need the data transformers. Because it could be that someone would like to create an application where he would like to get access to the real-time data for example, the Wi-Fi connection in this conference room. He would like to get information about the host, alerts, blah, blah, blah. Yeah? And he just want to have, for example, the name here, this one. He would just want to show up the name on the dashboard. So he can discard all of the stuff here. He just wants to have this ID, maybe the clock and the value, and this name here. We provide, first of all, anything, and the transformer defined by our administrator who's using the system. The transformer then transforms the data in a way that he wants to use it. And this is an example of the JavaScript transformer, yeah, of how to use it. And those guys, there was a workshop also for JavaScript script item type today's morning. Yeah, if you joined that one, then this one should be really familiar to you. So we have a function transform, it gets the input, which is all the raw data we just have seen on the previous slide. And then you can do transformations any way you want. You can rename stuff, you can discard stuff, and you can also create new values. Like in this example, we create a new value called non-zero, and this non-zero is depends on the value of some value of your historical data here. Very easy to use. And you can chain, combine, whatever you want. Yeah. So very flexible. So the tons of data we saw on the previous slide is just reduced to 1, 2, 3, 4 attributes for each entry, which is fine, which is exactly what, in this case, our application maybe requires. So these are the metric streamer implementation. I said on the first slide, starting with this topic, that there is somehow the ability to monitor the performance of the application, very similar to, for example, you would monitor a Zabbix proxy performance or would monitor the Zabbix server performance. So we do pretty much the same thing here. So we have a template that defines some metrics, which are overall metrics. And then we are using the wonderful low-level discovery feature from Zabbix and allow to discover all of the data things, all of the root definitions, and all of the data sources automatically. And here you see the prototype definitions, and then it will create all of this, and you can monitor this metric streamer big data collector in real time using Zabbix or using Prometheus. Which leads me to the last one, yeah? And the last one is, I said 5 examples, so that was the 4th example, now we are with the 5th example. And the 5th example is a simplified frontend access. And the simplified frontend access was self-provisioning, and many thanks here to the team of the Second German Television, by the way, for their valuable feedback. They really made the app better. Is we had very simple scenario. So we have people, different people using Zabbix actually, yeah, and they have different needs. I mean, some would like to get this high-level view, like this red, yellow, and green view for example, a service. It's fine. It's a manager view. I just want to know, does our web shop service work or not? And that's fine. And we have people working with the stuff, and they need to have all the core details. They need to understand that there's a ping missing, that the process is memory low, you know, all of this. I mean, we are on a monitoring conference. So different requirements for different group of people. And here the requirements have been that we need some very simple dashboard-like view. We need easy access to open and close problems, because that is what most time people deal with. Easy access to related metrics and their values. Related means metrics related to a problem, not to a host. Ability to acknowledge or comment on problems. The functionality you use from your Zabbix dashboard already, but that should be possible here as well. And from a self-provisioning perspective, these both are very important, these ones here. Configure notifications themselves and configure maintenance themselves. So currently it's a way that if you would like to configure notification, you have to set up an alert, you make sure that you have the proper host group or user group or media types, whatever. And people just want to have a very simple access saying, I'm interested in getting notified if in this group something happens with a severity of at minimum warning, for example. Yeah, support for multiple Zabbix servers should be possible, and of course no modification to Zabbix source code to be update safe. That is the software design. On the left-hand side, we see our Zabbix infrastructure, yeah, front-end, Zabbix server, Zabbix database, very easy. Then we have in the middle our what we call IntelliMon server, who does all the heavy lifting and uses the Zabbix API to talk to the Zabbix infrastructure, has its own database to do some caching, some optimized queries, etc. And then we have what is called a gRPC proxy, because we are talking here gRPC, and gRPC is the Google's microservice protocol. So if you're using Kubernetes, if you're using Docker, if you're using this microservice stuff, you will find that most of them is based on gRPC. It's HTTP2 binary protocol. Yeah? If you're interested in very interesting, visit grpc.io and then you can read all of the stuff. So we are using this protocol, by the way, to be more efficient. And then we have a web client using HTTPS, and that finally connects them to this infrastructure. And this is how the simplified front-end access implementation looks like. That is a screen here. And it's important to notice that, for example, we have here this My Alert subscription and My Maintenance settings. And really, it's as simple as that. You select a host or a host group here. You select the severity, and then you can define where you would like to get notifications on it. Will be a slide, I guess. Yeah, but that is how it looks like. These are the pages with the issues, yeah, with the problems, and then you can click on a host, or you can click on details. In this case, we are clicking on details. Get all the details. It shows here the related items, those defined in the trigger definition. And then you can, for example, say, I would like to get a graph over the last 1 day, 30 days, 70 days, whatever you would like to get, and then can you see this information. Yeah. So very easy to use. This is nothing new here. I know that is no new information. That's all coming from Zabbix and from the Zabbix API. But the point is, it's very easy to use. It's very easy to access. Yeah, and give some quality of life improvements, like this self-provisioning stuff, for example. Yeah, I promise that the self-provisioning is an important part. So, for example, if you would set up a maintenance here, very easy. You just select a group or a simple system. You just click on this icon here, which should show you that it's something with work, with maintenance. You just click on that, and then your system is set on maintenance. And if you're ready, you click again and set, I stop maintenance, and then can make a choice whether you would use data collection or not, apply to subgroups or not. It's very well integrated. Requires, of course, sufficient permissions. Yeah, front-end access, the same thing. You select the severity, and everything is fine. Yeah, advertise mode on. Yeah, feel free. We are giving away 20 subscriptions here. So if you you would like to give us a visit at our booth, and you have a chance to get something for free. Other than that, we made a mobile app for that one here, and it's available on iOS and Android, and it's great. It's working really good. So thank you so much for listening. Yeah, and and that's it. Yeah, that's.